Let us solve some applications of derivative, starting with number 1. What number exceeds its square by the maximum amount? For this to be simpler, let us put all given values first. We have here our mystery number. Let us put our number as x. And it says here that that number would be exceeding its square. So x here would be greater than its square itself by the maximum amount, which we will be looking for later on. And in order for this to become an equation, based on the statement, that number exceeds its square, so x here would be greater than this one, which we had done it, and put x squared to the other side, which would be x minus x squared. And since our operation here is a minus sign, it would be equal to the difference, which is, let's put this as d. If it is a positive, or I mean a plus sign, it would be equal to sum. But since what we have here would be a minus sign, it is equal to its difference. And the next step after we had done our equation would be to take the derivative on both sides. Starting with this first one, it would be the derivative of d over respect to x. Since our variable here is x, it would be respect to x. b equal to the derivative of x would be equal to 1, and the derivative of x squared would be equal to 2x to the power of 1, or simply 2x. Next step would be to get this one and equate this to 0, which would be equal to 1 minus 2x equal to 0. After that, we must isolate x here in order to get this value. So this would be 1 equal to 2x, divide both sides by 2. X here would be equal to 1/2. So this would be our answer right here, or our mystery number. And in order to confirm whether this would be the maximum amount, let us use this in order to find our second derivative. And for this one, the derivative of this one again would be equal to the second derivative of d with respect to x would be equal to the derivative of 1 would be equal to 0, and the derivative of 2x would be equal to 2. So 0 minus 2 would be equal to -2. And if it says that it would be the maximum amount, it should be less than 0, which is true because -2 would be equal to 0. If it says that it is the minimum amount, then it should be greater than 0. But since what we have here would be the maximum amount, -2 here, or the second derivative of our equation, would be equal to, or would be less to 0, which proves that x equal to 1/2 would be our maximum amount of number that exceeds its square. Number 2, what positive number added to its reciprocal gives the minimum sum? For this again, let x here be our mystery number. And we can now make our equation based on the statement. It says here that what positive number added to its reciprocal, so this would be x plus its reciprocal, which is equal to 1 over x, gives the minimum sum. Since our operation here is a plus, it would be equal to sum. Right, I just realized it is stated in here, it is sum. Now that we have our equation, next step would be to take its derivative. For this one, it would be the derivative of s over respect to x equal to derivative of x once again would be equal to 1 plus the derivative of 1 over x. Let me just put the steps here in case you didn't know. Whenever you are dealing with a fraction in here, it is best to put x into the numerator, and by doing so, its exponent would be reversed, which makes this x to the power of -1. And taking the derivative by power rule, it would be equal to -1 multiplied by x to the power of negative 1 minus 1 would be equal to negative 2, or this would be equal to negative x to the power of negative 2. And we don't want any negative exponents here, so we can put this to the denominator again, which would be equal to negative 1 over x squared, which would be the derivative of this one. Now that we have this, we can equate this to 0. And isolate x. So x squared right here would be equal to 1. And taking the square root on both sides, x here would be equal to plus or minus 1. But in our problem, it is stated here that what positive number. So this would be just simply equal to positive 1. So in order to check whether this would be our minimum sum that it is given, take the derivative of this equation again, or the second derivative. Starting with this one, it would be the second derivative of s over respect to x, and the derivative of 1 would be equal to 0, minus the derivative of 1 over x squared. Just use the same step that I did earlier, and you should end up with negative 2 over x cubed. Since what we have here would be a both negative, it would become positive, which would be equal to 2 over x cubed. If you had any variable such as x left, you can substitute our founded value here, which is equal to 1, which makes this 1 cube, which is also equal to 1. So 2 divided by 1 would be equal to 2. And you can see here, in the maximum sum, it should be equal to, less than 0. But in the minimum sum, it is the opposite. The number that we have gotten here should be greater than 0 in order to prove that it would be the minimum amount. So since what we have here would be 2 greater than 0, it proves that x here, x equal to 1 would be the minimum sum.